Happy day students. Today we are going to learn about moment of inertia of rod. That means here four conditions we are going to discuss. One is, for example, this is the rod. From this along this line, this is called axis of rotation. From the center of axis of rotation, what is the moment of inertia? Same from the rod, from the end to end. If the particle is here from this end, what will be the moment of inertia? And a number of rods like this, if the rods are connected in the form of square, what is the moment of inertia along this axis and from this corner and from center? Okay, and at an angle, it's an angle. Okay, that means it is the center of rotation. Now it is like this, it is going to rotate like this. In this case, what it is? Okay, these are all we are going to learn in this class, right? Let's see now. First one. So from the center of from the center to the axis of rotation. So this is the rod of length L and its mass is m. Okay, from the center. This is called as axis of rotation. So let's consider IC through the center of mass. Moment of inertia will be IC. So what is the formula for moment of inertia? M r square, where m is the mass and r is the perpendicular distance to the center of the axis of the rotation. Okay, right. So if this total length is L, then what will be this length? This will be L by 2. What about this? This is also L by 2. Okay, so one will be taken as positive, other will be taken as negative. Okay, from negative to positive it is going to changes. So what here it have only length. Okay, rod have only length, so it have linear charge. Okay, linear mass distribution. That means, so total mass per total length equal to dm by dx. Okay, dm by dx. So from this, dm equal to m by l into dx. Already we know the formula to find the moment of inertia. What is that? I equal to integral r square dm, where r is the perpendicular distance. Here what is the perpendicular distance? L by 2. Okay, so I equal to, from where to where? Minus L by 2 to plus L by 2. So let it write r square dm is what? This is the one. So m by L dx. So I equal to integral which is constant, m by L is constant, so take common m by L. R square, r is nothing but what here? I mean it's nothing but x distance, so it's an x square dx. So I equal to m by L integral minus L by 2 to plus L by 2 x square dx. Okay, so from this we need of integration. Okay, I equal to m by L integral x square dx, it is x power 3 by 3. So minus L by 2 to plus L by 2. So I equal to m by L of, what is simplification? 3 can take common out. Then x cube, x place, like you just replace it L by 2 and minus L by 2. That means L cube by 8 plus L cube by 8. Okay, x is nothing but L by 2. L square by, sorry, L cube by 2 into 2 into 2, 8. Okay, so m 2L cube by 3L into 8. 2 ones are 2 fours. So at center of mass it is m L cube. Center of axis of rotation ml cube. 4 3s 12 ml cube by 12 L. L here L gets cancelled. So IC equal to m L square by 12. Okay, so this is the total length. IC equal to ml square. So here small l, capital L, there is no varies, both are same only. Take as capital L. Okay, clear, right? So this is regarding around the axis of rotation. Then what will be from the center? What will be from the center? If this is the rod, from this point I need. Okay, let's consider a small element here. of dm. Already we know something. What is that? That is from the center we know. Center from the axis of rotation. This is inos. What is this? Total is ml square by 12. So from here to here, what is the distance? R. Then from here to here, one end to other end, total distance is L. From 0 to length L. I equal to integral R square or x square dm. So I equal to integration from where to where? From 0 to length L, x square. Dm is what here? Dm equal to m by L into dx. Same m by L into dx. Rod only, no? So m by L into dx. Then I equal to integral 0 to L. M by L is common. Then x square dx. Then I equal to m by L. X square dx means x power 3 by 3. From where to where? 0 to L limits. So m by L into L cube by 3. Okay, clear? Then what you will get? It will be m L square by 3. So ml square by 3. Got it? From one end to other end, it will be ml square by 3. Okay, na? Clear? Okay, next. So what we have done? So x of rotation from the end of the rod. Now the rods are in the form of square shape. So this is one rod, here one rod, here one rod, and here one rod. Okay, four rods. First rod, second rod, third rod, fourth rod. Each length is, each mass is m and each length is l. Okay, so from where we have to take the axis of rotation? According to the axis of rotation, moment of inertia will be changes. It might be changes, may not be changes, but most of the cases it will be changes only. So here we have taken three conditions. Here possibility of three conditions. One will be along this axis, one might be along this axis. We can consider this axis also. This axis same. This axis and this also same. Okay, that's the one condition. And from the corner which is perpendicular to these two, which is perpendicular to these two, from that also you can get one. And from the center of this, three you will get. Right? So with the three rotations we can find it out. So now we are going to do about from first rod. Okay, this rod axis of rotation. So for this, here will be the center, right? So for this will be the center, right? So this have one moment of inertia, this have one moment of inertia, this have one moment of inertia, right? So what is the total moment of inertia? I equal to I1 plus I2 plus I3 plus I4. That means all are about to be added. So from this rod, this is the center, right? So from how to find it? It is whether this rod is going to rotate like this or rotating on by own itself. It is rotating on by its own. That means moment of inertia for I1 is 0. What about for I2? What about for I2? I2 is nothing but from this point. This is the axis, parallel axis theorem. Okay, these two are parallel. According to the parallel axis theorem, what's the formula? I equal to IC plus m r square. So at what distance it is? It will be an L by 2. So I2 equal to, what is the IC at the center of mass? Just before we done, what is it? This is from end, from the center. What is it? ml square by 12. So from the ml square by 12. So ml square by 12 plus m r. What is the distance here? L by 2 whole square. So I2 equal to what? M L square by 12 plus M L square by 4. So from this what you will get? M L square by 3. Same that only now we got before also. right? Fine. So I1 is 0, I2 is ml square by 3. Then what about I4? What about I4? I4 is also ml square by 3. Then what about IC? IC from the center it is 0. So I equal to I1 is 0 plus ml square. I2 is ml square by 3 plus, let me write I4. I4 is ml square by 3. What about I3? What about I3? I3 equal to I3 equal to IC plus mr square. What is the IC at the center of mass here? What is the center of mass? From this, it is 0, remaining mr square. What is the m? R. R is nothing but L square. This total length is L only, no? From here to here, total length L. When it is rotating on its own axis, it is 0. Okay? So IC equal to ml square. That to be substituted. ml square. So then I equal to, after ml square by 3, ml square 2 ml square by 3 plus ml square. So this will be 3 plus 2, 5 by 3 ml square. Okay, clear? So answer is 5 by 3 ml square. Okay na? Next, now the same rods but are from the corner. From this corner, what are the moment of inertias? Okay, same mass, same length. So this center of mass, this center of mass, this center of this center, moment of inertias. Okay, then what about this length? L by 2. What about this length? L by 2. L by 2. So L by 2. Here is also L by 2. Here is also L by 2. So this is the center point. Just consider just a point. Okay, right. Now from this point, if you want to find from this corner, this side and this side, same moment of inertia will be there. That means first rod, second rod, third rod, fourth rod. That means I2 and I3 will be equal. Similarly, I1 and I4, from this point it is at what distance? This is also at same distance, right? So I1 and I4 will be equal. So I want to find whether I2 or I3. Similarly, I1 and I4. Okay. So from the axis of rotation, from the parallel axis theorem, I equal to IC plus mr square. So I equal to IC from this end to this end. What is the total length? L. What is the IC? IC is m L square by 12. From the center. From the center is ml square by 12 plus m r square. R is means from this. This is at what distance? What distance this is? We don't know. This is the distance which is. Okay. That means you have to take this as a triangle. So from this triangle, this is L by 2. This total length is L. So what about this length? It is, this length is L by 2 and this total length is L. Then this length will be how much? Hypotenuse only, no? So hypotenuse means that hypotenuse will be equal to root over L by 2 whole square plus L square. So that will be how much? 5 root over 5 L square by 16. 16. See, solve it clearly. So it is root over, wait, root over L square by 4 plus 4. 4, this is L square. So it is 5 L square by 4. So it's root over 5 L square by 4. Okay, clear? Right. So you can substitute that here and find the I. This is for I2 as well as for I3. Both you will get same. Okay. Similarly, you have to find for I1 and I4. So what for I1? I1 is at a distance of same IC plus m r square. This is for I1 we found. Oh, okay. Next, then I1 is ICML square by 12 along the center of axis of rotation, ml square by 12 plus mr square. So mr square means what distance? Second rod. This rod or this rod, what distance? This is second rod, this is third rod. From this, at what distance it is? What distance? It is half only, no? L by 2. So m L by 2 whole square. So ml square by 12 plus ml square by 4. Already we just done, that is ml square by 3. Okay, this ml square by 3, and from this you will get, I will tell you the directly and you solve it so that you can learn it. Okay, so this is I1, this is I2, I2 or I3, both will be same. I3, this is for first one, no, so it is I1 or I4. So I1 and I4, this will be 4 by 3 ml square. Okay, clear? I1 and I4 both will be 4 by 3 ml square, and I2 and I3 is ml square by 3. What is the total moment of inertia? 2 into 4 by 3 ml square plus what? Ml square by 3, ml square by 3, how many? 2 are there, so 2 into ml square by 3. So if you will take 2 ml square by 3 common, then it is 4 plus 1. Okay, then it is 5. So 5 to 10. So 10 ml square by 3. So this is the moment of inertia from the corner. Okay, clear? Next, you do the sum for this one. So same mass rod, same first rod, second rod, third rod, fourth rod. From the axis of rotation, from the axis at a distance of this L by 2, and this is also a distance of L by 2. Now you need to find from the center of axis of rotation. Before we found for two things, here and as well as from this corner. Now I am asking you to find from this. You try to find the answer for this and comment it in comment section. Okay, right. Next, so what we have, one more, that is with the angle, with an angle. So for example, I have a rod. This is the rod. This is the rod. From the axis of rotation, this is, it is going to rotate in this direction. Okay, so this is going to rotate in this way. So the rod of length is L and its mass is m. So small element of mass is dm and small element is dx. Okay, let's consider it is making an angle theta. So what will be this distance? What will be this distance? Its radius only, no? What is that radius? If this is theta, then what about this? Then r equal to, this total length is L. This will be taken as dx, so it will be, how much it is? At a distance of x, so it will be x sine theta. Okay, so that will be written as x sine theta. Got it? Then what about this dm? dm equal to m by l dx. dm equal to m by l dx. Okay, generally we are finding for dm, right? Now I equal to integral x square dm. So I equal to integral from where to where? From 0 to length L. From 0 to length L. X. X is what here? X is, don't know. So x square into dm in, dm means what? This is the one. M by L dx. Clear? Right. So I equal to, here m by L is constant. M by L is taken out. Integral 0 to L x square, 0 to L x square dx. Okay, what about x square here? X is nothing but distance only, no? That is this distance. How to find this distance? This is the distance. How to find the distance? It is an opposite side. Opposite side means sine theta. What sine theta it is? What sine theta it is? It is x sine theta. Why it is x? According to the sine theta equal to opposite side by hypotenuse. Okay, here hypotenuse, this distance we have considered, this is at a distance of x, that's why it is dx. Okay, sine theta equal, so x equal x sine theta, this is the radius. So I equal to m by l integral 0 to l x square sine square theta dx. Here theta is constant, with same constant it is rotating, so sine square theta is also taken common. Then I equal to m by l sine square theta integral x square dx from 0 to l. So I equal to m by l sine square theta into x cube by 3, that means l cube by 3. Here one l gets cancelled. So I equal to m l square by 3 sine square theta. Okay, this is the moment of inertia of rods.